The deformation takeoff process you're referring to likely relates to the unique takeoff mechanism and transformation of the V-20 to Osprey, an advanced tiltrotor aircraft used by the U.S. military. Here's an overview. Key features of the Osprey. 1. Tiltrotor technology. The Osprey combines the vertical takeoff and landing VTOL capabilities of a helicopter with the high-speed, long-range capabilities of a turboprop airplane. This is achieved through its rotors tilting between a vertical helicopter mode and a horizontal airplane mode. 2. Deformation-like transformation process. The process looks like deformation because of the significant physical movement during its tiltrotor transition. In vertical mode, the rotors are positioned perpendicular to the aircraft's fuselage, allowing for takeoff, hovering, and precise vertical maneuvers like a helicopter. As it transitions to forward flight, the rotors slowly tilt forward to horizontal airplane mode. Steps in the takeoff process. 1. Vertical takeoff. In VTOL mode, both engines and their connected rotors are tilted vertically. The aircraft lifts off the ground like a helicopter by increasing the rotor speed, creating the necessary lift. 2. Transition phase. After achieving the desired altitude, the nacelles engine housings that include the rotors start to tilt forward gradually. This is a synchronized process requiring precise coordination between the engines, nacelles, and control surfaces like flaps and rudders. Pilots monitor airspeeds to ensure stability during the transition. 3. Airplane mode. Once the nacelles tilt entirely forward approximately 0 degrees relative to the fuselage, the Osprey behaves like a fixed-wing airplane. It achieves significantly higher speeds, around 280 knots, and longer ranges compared to helicopters. 4. Reverse transition for landing. When landing, the Osprey transitions from airplane mode back to helicopter mode, tilting its nacelles back to vertical. This process can occur in midair for hover landings or close to the ground for standard VTOL landings. Close-up of mechanisms. The transformation involves powerful gearboxes and drive shafts connect the two engines, enabling synchronized rotor tilt and power sharing. Swivel nacelles, heavy-duty, swiveling mechanisms allow the rotors to tilt smoothly between modes. Aerodynamic adjustment. During the transition, computer systems make constant adjustments to maintain stability, compensating for shifts in lift, thrust, and aerodynamics. The deformation visual is one of the most striking aspects of the Osprey and a primary reason it's considered a marvel of modern engineering. This capability has made it invaluable for military operations that require flexibility, like troop transport and medical evacuation.